All right, so in this lesson, the area formulas get just a little bit more complex, and you are going to be able to use a sheet for the formulas on our next quiz, because at least for areas of trapezoids, rhombuses, and kites, because they're a little bit rarer shapes, they don't show up as much, so memorizing the formulas isn't as important. So I'm going to start with the area of a trapezoid, and the area of a trapezoid is 1/2 times the height times the sum of the bases. So just remember, the two bases are both perpendicular to the height. So if I have in example 1, a trapezoid with a height of 7 and bases that are 12 and 15. So I'll say base 1 is 12, base 2 is 15. And as far as the bases go, it doesn't matter which one is base 1 and base 2 because they're being added together, so the order doesn't really matter. But when I write this out, I'm going to write out the full formula. The area is 1/2 times the height, which is 7, times base 1 plus base 2. So 12 plus 15. So that simplifies to be 1/2 times 7 times 27. So the area of that trapezoid ends up being 94.5 square centimeters. So that one was easier because I literally gave you the height and both of the bases. You're gonna have to do this based on a diagram later, but we'll get to that once we get to the back side of this sheet, or these notes. Moving ahead, rhombuses and kites actually have the same formula for area, and it's another one where we multiply by 1/2. And the area of a rhombus or a kite is just 1/2 of the product of the lengths of the diagonals. So in example 2, we're just going to practice using this formula. The area of this kite, I'm going to label the diagonals, diagonal 1, diagonal 2, and a diagonal reaches from one vertex to the opposite vertex. So one of the diagonals is 3 plus 3, which is 6. The other diagonal is 2 times 5, which is 7. So the area of this kite is 1/2 times 6 times 7, which is really 3 times 7, or 21 square meters. And what I think is an interesting thing about this is that it simplifies, because honestly, when you draw two diagonals, you essentially create 4 triangles. So if I look at this triangle right here, the area of that triangle is 1/2 times 2 times 3, which is 3, which would be the same area as this triangle, which is also 3. The triangle to the right of that, I'll do that in blue, this triangle is 1/2 times 3 times 5, which is 7.5, making the other triangle 7.5 square meters. So if I do 7.5 plus 7.5 plus 3 plus 3, I still get 21 square meters. So it's kind of like a shortcut for finding the area of a kite or a rhombus. So honestly, that does cut us out a lot of time to find these areas. So if I go to finding the area of a rhombus, and I'm going to draw this one for example 3, but if a rhombus has sides of 10 centimeters, so I'm going to draw a rhombus, all 4 sides are 10 centimeters, okay? The longer diagonal is 16, so we'll just say this diagonal is 16. What is the area of the rhombus? If this longer diagonal is 16, a couple of things about rhombuses. Their diagonals intersect at a 90-degree angle, and the diagonals cut each other in half. So this diagonal has lengths of 8 and 8 to split it up, okay? The reason I split it up is because it creates a right triangle, and I'm just going to cut out one of the right triangles. This side is 8, this side is 10. We're going to have to go back to our memory banks and remember that we can find the measure of one of the sides of a right triangle if we know the other two sides by doing a squared plus b squared equals c squared. So a squared plus 8 squared equals 10 squared. 100 minus 64, a squared is 36, so a must be 6. So my diagonals are going to be, one of them is going to be 16. The other one is going to be 6 plus 6, which is 12. So I know I kind of jumped around a little bit, but we got to do a little bit extra work to find the measure of both diagonals. So that a squared plus b squared equals c squared is going to pop up from time to time, so we need to remember that. So the area of this rhombus is going to be 1/2 times 16 times 12. And again, use your calculators for stuff like this. That's what we have them for. So 1/2 times 16 times 12 is going to be 96. And we don't forget the units. It's going to be in square centimeters. Okay, square centimeters. So when I flip to the back side, when I go to the next page, you are just going to be doing some guided practice. So what I'd like you guys to try and do, and I know you're going to have to flip back and forth, I apologize for that, but see if you can find the areas of each of these figures. Number 6, I want you to circle, because number 6 kind of repeated a question I already did. So if you don't do number 6, that's honestly okay. I kind of didn't realize I repeated that example from example 3. So just take a minute, pause the video, take a few minutes to work through these 5 at least, and then I'll try and explain number 6 a little bit more, but really 6 is the same as example 3. Okay, so to go through these answers, I'm just going to basically put problems 1 through 4, or 1 and 2 up. I'll leave them up for a few seconds, let you check over your answers. Then I'll move down to 3 and 4. Let you check those answers. And then move down to 5 and 6. And 6, I probably should have done a problem with different numbers. But essentially, if you're given a rhombus, you know, or a kite, the diagonals are going to meet at a 90-degree angle. They're going to be perpendicular. So if you know one of the diagonals, you can find the other by using a squared plus b squared equals c squared. That allows you to find the other diagonal, which helps you find the area. So pretty short notes, only a couple formulas to follow, but I really want you to get some practice with using these formulas, understanding what a diagonal is, understanding the bases and heights of a trapezoid, and applying them to find different areas. Now the problems do get more complex in the practice, so if you have questions, please email me or let me know, and I'll do my best to help you out. But make sure you go through the next activity, make sure you do all the problems I assign in the practice, and make sure you do the checkpoint last. It is important that you do the checkpoint last, always. That's where you see where you're at the end of a lesson, to see if you need more help or to see if you're ready to move on. So you can move on to the next activity. Make sure you do the steps of the lesson in order.